This problem and all other CALC 152 problems can be found here at Sarai Studies. Link is in the description box below. I look at this and I ask myself, is there anything that I can strip away as n gets really big? In other words, is there anything that's insignificant, like a +1, right? Because what is a +1 going to do to infinity? So as n approaches infinity, and I don't see that. So I'm not inclined to use a comparison test like DCT or LCT, because then I will not be able to find a B of n, a sequence to compare to. But what I do see is that both of these are raised to the nth power. And then recall that a root test is based on the limit as n approaches infinity of the nth root of the absolute value of A of n. So if I use that, I'm going to be able to cancel these out. This is actually equal to a limit or rho. This is not P. This is not the same as the P in the P test. This is pronounced rho and it's spelled rho. But if you don't want to use that, as long as it's okay with your professor, you can use L for limit. So what are the rules? The rules are if rho is less than 1, greater than 1, equal to 1, then it converges, diverges, inconclusive. And we say converges absolutely when we're doing ratio or root tests because they're absolute convergence tests. So we take the limit of the nth root of the absolute value of our sequence A of n, which is 5 to the n to the n. And then we realize that we don't even need absolute value because n is equal to 1 is the least that can ever be put in here. So if we plug in 1, 1, 1, we get 5 over 1, which is just 5. So the least term that this series can have is 5. So it's never going to be negative anyway. So we can just take away the absolute values because we already know that whatever this is going to be positive. And then we can use our algebra rule. So this becomes the limit as it approaches infinity. And then you just split it up, 5n to the nth power, and to the nth power. And then these n's cancel out. And then you're just left with this. And this is 5 over infinity. And remember that when you have one whole, forget about the 5. If you have one whole, you divide it into infinitely small pieces. That whole becomes infinitely smaller. So small. You can barely see it. And it's basically 0. It's limited to 0. So same thing with 5 wholes. So it's 0. And so this is a rho or a limit, whatever you want to use. So because rho is equal to 0, which is less than 1, then therefore our series converges absolutely. But the question was, does our series converge, period, not if it converges absolutely. So then we would have to use the absolute convergence theorem that says that if a series converges absolutely, well then the given series with the absolute value converges. So just what we want, right? So for our conclusion, we say since, and then we just literally copy the limit, say that it's equal to 0, which is rho, which is less than 1, then the root test implies that, and then just take your original series, converges absolutely. And by the absolute convergence theorem, absolute convergence implies convergence of that same series. So we can say that this series converges. And that's it for this video. I'll see you in the next.